Welcome to a lesson with Dr. Powell. Let's take a look at another example of finding the centroid. This time, let's take a look where we have a top function and a bottom function. Perhaps we have again y is equal to x squared. But then let's look at a line. Suppose we have a line that passes through this point at -1, and then goes up here to this point here at 2. Okay, so the point from here to here. All right, and make that a straight line, and let's find the centroid of this shape inside here. So we have a bottom function here, y equals x squared. We just need to know what this is right here. Well, we know that the slope of this, so this is going to be a y value is 4 and the y value is 1. So that's a rise of 3, and we're actually slope of 3 here as well. So so it's going to look like something like, or a run of 3, that is. So it's going to look something like y equals x, and then where does it hit the axis? Well, think about it as we go 1 over here, we're coming up 1 here, so it's going to be just at 2, so plus 2. X plus 2 would give us that, and we could check it, plug in -1, you get 1, and you plug in 2, you get 4. So you have, this is the top function, so this is at the top and this is at the bottom. Okay, now let's proceed and figure out what x bar is. First, using kind of our analogy of mass variable, we're just finding the average value of x with respect to, thought of as a function of m, with respect to m, as the mass, as the mass or the area starts here, and we look at the mass up to a point, or the area up to a point as we go, as it goes from here to here. So we need to know how long the mass interval is, or the area interval. So we just need to know what the total area is of that. We can do that by computing x plus 2 minus x squared. So top function minus bottom function from -1 to 2. Okay, so that would be, so then we would have x squared over 2 plus 2x minus x cubed over 3, going from -1 up to 2. We can plug in 2, and we end up getting 2 plus 4 minus 8/3. Plug in -1, we end up getting 1/2 minus 2, and then we get plus 1/3. Okay, then we need to subtract that off. Okay, so we'd have 6 plus 2, which would be 8. So we have 8 minus 1/2, and then we have so it's 9/3, so 3 plus, yeah, so minus 3, and so we'd end up getting 5 minus 1/2, which would be 9/2. So okay, so that would be 9/2. So that would mean that in this, we would take the reciprocal of that, because it's like 1 over the length of the interval, and we're going from, the area starts at 0 and builds up to 9/2. So 1 over that would be 2 9ths. Okay, and then we just need to, and then the x value is going from -1 up to 2, and dm in this case, well, think about what dm is. A little change of mass, can be represented by a rectangle here, a rectangle at a particular x value. So at that x value, think about this rectangle. Its width is dx, and the y-coordinate of the top and bottom, so the y-coordinate on the top is at a particular x value, is x plus 2, on the bottom is x squared. So the height of this rectangle is simply x plus 2 minus x squared. So we have that the area of this rectangle, which is equal to dm, would be quantity x plus 2 minus x squared, and then a dx, just like what we used here, actually. In fact, the same thing you put in here to find the area, you put in here, and it is your dA or your dm. And that's exactly what you put. So same thing in the area calculation you put here, but you're putting an x here because you're finding the average value of this as a function of with respect to m, and this is like your dm. Okay, so then we proceed and we to integrate this out. And so we first multiply that, x squared plus 2x minus x cubed, 2/9, and okay, and we're going to integrate that. Okay, so we have x cubed over 3 plus x squared minus x to the 4th over 4 from -1 to 2. Okay, we can erase this work right here. And then we have 2/9 times all of that, right? Okay, and so that would be 2/9 times 8/3 plus 4 minus 16, so 4 minus 4. That's kind of nice. Right. Okay. Yeah, that makes sense. Okay. And then you have minus what you get when you plug in -1. So you have -1/3 plus 1 and minus 1/4. Okay. Right. I think that's right. Okay. So what we end up getting, so this is like plus 1/3. So added with that would be like 3. So you get 3, and then you have -1. So that would be 2, and then plus 1/4. So it's 2 and 1/4, which would be 9/4. So you get 9/4 times 2/9. So 2/9 times 9/4, which would end up being simply a half. Great. So, and see if that makes sense. Yeah, that makes sense. Yeah, the x bar would be about a half. Okay, so x bar is a half. Now, to find y bar, we do the same thing. We have the same integral setup, but we replace x now with the average y value at a particular position x. So we just find the average of the top and bottom function. In fact, if we want, let's kind of do this symbolically because it makes things a little simpler. If we thought of the top function as f and the bottom function as g, then what we're doing is we're finding the middle y value. So this is dx, this is like your dm. Then what we're doing to find our middle y value, okay, and we still have 2/9, the middle y value is we just take the average, f of x plus g of x over 2. Notice why this is nice, because this is a difference of 2 squares factored. So we really just get f of x squared minus g of x squared, and the 2 we can pull out here, and it just becomes 1/9 out there. So we're going to end up getting 1/9 times the integral, still from -1 to 2, of just the top function squared, which I'll multiply out, x squared plus 2x plus 1, or plus, no, 4x, excuse me, 4x plus 4. I'm just squaring x plus 2. Subtract off what x squared is squared, which is x to the 4th. And that's all I have. And I already put the 2 in, and I put it right there, so I have 1/9. Okay, so then I just integrate that. X cubed over 3 plus 2x squared plus 4x minus x to the 5th over 5. 1/9 multiplied to all that. and we're going from -1 up till 2. Okay, so then we put 2 in. So we end up getting, let's see, 8/3 plus 8 plus 8, right? Minus 32 over, 32 over 5. And we have 1/9 times all of that. Okay, and then we're going to keep this going because now we're going to subtract off what we get when we plug a -1. So we get minus, okay, quantity. So minus quantity, -1 over 3, plus 2 minus 4, and then plus a fifth. And if I'm plugging in -1, and then I have 2 parentheses since I have 1/9 outside of all that. So then I work that out, and I end up getting, let's see, I end up getting 16. Let's see, 16 and subtracting. So this is -2 and minus, so minus a -2 would be +2. So 16 plus 2 would be 18. So just looking at the integers, we got 18. And then looking at the fractions, let's think we have 8/3, but then plus a third, so that would be like 3. So I'm going to be adding 3 to that. And then we have minus 32/5, and looks like we're subtracting, so minus 33/5. Minus 33/5. Yeah, and I think it counted for everything there. And that's then multiplied by a 9th. So that would be what, 21. So that would be 21, multiply that by 5. So 105 minus 33, which would be 72. So we get 72/5. So 72/5 times a 9th. So it looks like 72 over 45, if I did my calculations correctly. All right. So we have X bar and Y bar. Thanks for watching.